All right. Hello again, everyone. Welcome to example 2. All right. In this example, we will once again find the resultant of two vectors, right? But in a slightly different way from example 1. So, what we have is Lloyd walks 60 meters at 50 degrees north of east, and then he walks 95 meters at 75 degrees south of east. Okay, so those are his two vectors. So first of all, let's draw a picture. I'm only going to draw one half, right? Two quadrants here, because we have Lloyd walking north of east and south of east. Therefore, he's always going east. So I'm not going to draw the left half. So let's make north equivalently to the y direction, and then east equivalently to x. All right. So we can say that Lloyd starts at the origin, and then he walks 60 meters at 50 degrees north of east. Right. This way of wording can be confusing, right? But let's take a look at it. North of east, right? That means north from east. So we have to find due east, which is to the right here, and we go north of that, which is, straight up. Right? So north of east at some angle is actually this way, right? Counterclockwise. Conversely, south of east, like it says for vector 2, is south from due east. That's what that means. Okay? So starting at the origin, I'm going to try and get the magnitudes somewhat close. 50 degrees is just past halfway, so let's do something like that. All right, let's call that vector A. And this angle here is 50 degrees. Okay? Then, from that point, he walks 95 meters, 75 degrees south of east. So that means from this point here, we need to determine this angle, right? So I'm going to do that by drawing a mini axis, if you will, from right there. So that's also due east, and then he needs to go 75 degrees south of that. I'm going to consider that to be, 90 minus 75 is 15. So 15 degrees away from due south, in other words, right? 75 degrees south of east is a big angle, right? So the complement is 15. So let's do it like this. So then he goes, well, that's not even 15. Let's do it like this. Something like that. Does that look like 95? I don't know. Maybe. I'm actually going to shorten that axis a little bit. Okay, and that will make vector B. And then this angle here will be our 75. Okay. All right. So, if that's our diagram, we want to find the resultant, which I'll draw. Actually, let's not do in red. Let's do in green. We want to find the resultant, R. Okay. Not only the magnitude, but the direction as well. So the direction with respect to x, right there. What's r and what's theta? The first step after you've drawn the problem, right, after you've written down everything you know, is to find components, right, of these vectors, at least in problems that deal with resultant vectors, okay? So, I'll get that out of the way. First, what I want to find are the components of A and the components of B, right? Specifically in the x direction. In the x direction, make this. I have been using blue. So in the x direction for A, it's going to look something like this, right? In the x direction for B, it's going to look something like this. Right? Something like that. In the y direction, I've been using red. For vector A, we'll have that, and the y direction for vector B will have this over there. Right? So this may look a little confusing. I'm going to draw another axis. Actually, tell you what. Yeah, I will. Okay. Now let's only draw the components. So we have AX, something like this. Now we have vector, and BX, something like that. And in the y direction, we have this, we have AY, and then BY. Remember, BY starts from this point up here, right, where AY finishes. Do I want to do it over there? I'm going to draw it. I'm going to draw it over here. So going back down. That might be hard to read. Tell you what, let's do this. Okay, that's AY. There you go, something like that. So BY is on the outside. There we go. AY is on the inside. Okay. All right. That's what we have pretty much for components. Okay. Now let's find them mathematically. So vector A was equal to 60 meters. Okay. At 50 degrees. Tell you what, let's do it like this. AX, right? Vector AX, vector BX were, well, the magnitude of A times cosine of the angle. So cosine of 50 in that case, right? And so that magnitude of A was 60. We'll put that in later. For right now, I'll leave it as A. BX was, well, the magnitude of B times cosine of that angle, and that is cosine of 75. Okay. For AY, we have that was magnitude of A times sine of 50. Again, that's sine because if 50 is our angle here, the opposite side is right there. Okay, and that's the same vector just translated as what I have written right there. Okay, so that's why it's the sine. That's why it's the opposite. And then BY, again, same thing. From that angle of 75, the opposite is right there. Okay, so that is magnitude of B times sine of 75. Okay. Now, let's make these into the vectors. What I have written here are all scalars. We have to put unit vectors afterwards. So the AX vector is going in the plus X direction. So that gets plus I hat. BX, same thing. AY, that's going up in the Y, so that gets plus j hat, and now by is actually going down, right, in the negative y direction. So that gets a negative j hat. Okay. All right. So let's move to the next slide. And we basically want to find what all of those components add up to. So r equals a plus b. Remember, this is the vector sentence or our vector statement. So Rx is equal to Ax in the I hat direction plus Bx, whoops, in the I hat direction. And similarly for the y direction, Ay, that's definitely a j hat, and negative by j hat. Right, well, sorry. Yeah, I'll put the negative in there now because that component is going down. Okay. All right. So let's plug in the numbers now, right? We have Ax is equal to a cosine 50. By the way, our magnitude of A was 60. So we have 60 cosine 50 I hat plus Bx was equal to magnitude of B, which was 95, and then cosine 75. All right, if we do the math here, our total x should be 63.16. Again, assuming your calculator is in degrees, right? For Ry, Ay is equal to the magnitude of A, right there, which again was 60 times sine 50. J hat minus now magnitude of B, which was 95, times sine of 75. And if you do the math here, you should get a negative number, negative 45.8. Oh, I forgot the units on these. That's okay. J hat. Okay. By the way, if you put in SI units, right, at the start of your problem, if you turn all your numbers into SI units, like I have here in meters, you don't really need to carry through your units with every calculation, right, in the middle of the problem. If you put SI units in, you'll get SI units out. So I guess I really don't have to include the units here and here, right? Just at the end when I box my answer for sure, okay? So, all right, we're there now. We're almost there. We have magnitudes for both the x and y components of R, and now we just need to find the magnitude of R. All right, again, from a Pythagorean theorem, all right, we have 63.16 squared, we'll do quantity, plus the negative 45.8 quantity squared, all square root, and we should get approximately, if my math was right at least, 78.02. meters. All right. And if we kind of look at our graph here, let's see, x was positive 63, y was negative 45, so x is like, what, 1.5 times bigger? I don't know. Anyway, the resultant, x should be positive, that's right. Y should be negative, the resultant, that matches. So it seems to be matching so far. Now we need the angle. And like before, we just use inverse tangent, right? Since we know both the x and y components, we can do this. But which is on top and which is on the bottom? Well, because we specified this angle right there, right? That angle there, our resultant, actually, let me draw that over here. Our resultant that's the negative y direction. That's r. If this is the angle, right, this was our ry, and this here was our rx vector. So the opposite to theta is ry, and that goes on top. So negative 45 divided by the adjacent, which was rx, 63.16. Right? And you should get something around the order of, hopefully it's a negative number. I got negative 35.95 degrees again. Right? So you could put a negative and stick with that angle convention as counterclockwise being positive, clockwise being negative, right? Or you could also say, what is that, 35.95 degrees south of east. Either one of those are fine. That's the overall magnitude of the resultant. And so again, in this problem, let's go back here. We first got a vector statement, right? And that means that the resultant r was equal to vectors a plus vectors b. And so that gave us this statement to write out, right? Then we took this exact form and wrote it out in x and in y, right? Then plugged in the terms for each of those using trig, got values, and then used Pythagorean theorem to get the magnitude, and then inverse tangent to get the angle as specified from positive x. All right, so thanks for watching example 2. I should have one more example. I will see you there. Thanks for watching.